All right, so this is where we left off in the first video. So in the second part, we are going to focus more on the unit vector and that ij form of a vector. Okay, so part two. So 7.5, part two. Okay, so unit vectors. So we said a unit vector, just like a unit circle, uh, a unit vector has magnitude 1. Okay, so we are going to focus on two very specific unit vectors, the I vector and the J vector. Both of these are unit vectors, and both of them have a magnitude of 1. Okay, so let's write that down. Magnitude equals 1. Um, and so here the I vector is the vector in standard position that goes out to the point 1, 0. Okay, and the J vector is also at standard position and goes out to 0, 1. Okay, and so let me show you what this looks like visually. Let me go over here. All right, so here, all right, so if I have this vector I goes to the point 1, 0. 1, 0 is right over here. So this would be the I vector. Okay, and then the J vector goes out to 0, 1, which is over here. So this vector would be the J vector. Okay, and now that you know scalar multiplication and addition, we can take a look at the ij form of a vector. Okay, so let's take a look at that. All right, so component vector form. So that's that ij form. Component vector form. This is also that ij form. Okay. All right, so if vector v is given to you in just regular component form, you have some value there and another component there, then ij form is given by this ai plus b times j vector. Okay. All right, so for example, if I have to write the vector component form, of v, which is negative 3, 7, then the ij form, or the vector component form, would be, I take that negative 3, and I take that 7, and that's it. Okay? Yeah, so you might already have a preference for how you like to write your vectors. You can see that there is less writing over here, possibly. Okay. All right. To me, this one flows better when I'm writing. Okay, so let's take a look at what this looks like visually. Okay, so here, so we have negative 3, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So negative 3, 7 is right here. So this is our vector v, negative 3, 7, right? And if we take a look at the each component, so and it's a lot easier to see it with this one because we know that I is that horizontal vector, right? That unit vector from 0 to 1. But if we multiply that unit vector, the one that goes like this, if we multiply by negative 3, then it ends up going this way to negative 3, right? So we have this here is the negative 3i. And then 7j, so that's this vector here, this little unit vector, the vertical one, multiplied by 7. So then that goes all the way up to here. And this is 7j, right? And what we end up having here is, again, vector v, we see, is the sum of these two vectors, right? So this one kind of allows you to see the two horizontal and vertical vectors that you're adding together to get the final vector. Okay, so hopefully you understood that. Okay, let's take a look at this here. All right, suppose that V is in standard position, and makes a 35-degree angle. So now we're getting into some trig here, and makes a 35-degree angle with the positive x-axis. With the positive x-axis. Okay. And suppose that the magnitude of V is equal to 15. Write vector V in ij form. In ij form. Okay, so that means that we need to know the x component and the y component. Okay, so let's go ahead and draw what we know. Okay, so it makes a 35-degree angle. So let's pretend this is 35 degrees here. Okay, and we know that it has a magnitude of 15, and I need to find the x component and the y component. This is the x component and this is the y component. Okay, and we've seen this before, right? We have a right triangle. We have to solve the right triangle, so we can use our trig ratios to find this. All right, so let's start with the x value. Okay, so if we're trying to find the x value, here's our angle, right? So the x value, this side of the triangle, the x component of the vector, this x value is on the adjacent side, and then we have the hypotenuse, right? And so let's bring back our SOHCAHTOA, right? So this is our h, this is our adjacent side, and this is our opposite side. Okay. All right. So if I'm trying to find x, that's our adjacent side, and we have the hypotenuse. So we are using cosine 35 degrees, which equals to x over 15. So 15 times cosine 35 degrees equals x. And so here this x equals to Um, oh, you know what? I kind of made a mistake, but here, let me just change that. Um, hold on. I need to get my calculator. Ugh, what's on my hands? Okay. Um, all right. So pull up my calculator so I can figure out what 30 cosine of 35 degrees is. All right. 15 times. You probably figured it out already because you're awesome students and you have your calculator handy. Okay, so we get roughly 12.3. 12.3 equals x. Okay. All right. And so let's go ahead and find the y value. So here we could do sine of 35 equals y over 15. So 15 times the sine of 35 degrees equals y. And if we punch that in, uh, 15 times the sine of 35, then we get 8.6. All right. All right, so we have the x component and the y component. So now we can go ahead and write this vector in ij form, because remember we need the x value here next to the I, and we need the y value here next to the j. Therefore, vector v is 12.3 I plus 8.6 j. Okay. All right, so there you have that. So if they ask you to write your vector in ij form, you need to have the x and the y component. And if you're not given the x and y components, then you have to use your trigonometry to find them. Okay? All right. And then adding, subtracting, and multiplying is still the same. So let's just take a look at that. Add, subtract, and let's just throw scalar multiplication in here. Scalar multiplication. Okay, so if you have vector u equal to 5i minus 3j, and vector v equals to negative 6i plus 4j, suppose you have to find this, a, u plus v. Then it's the same thing, because again, it's like this is your x component, y component. This is your x component, this is your y component. And so you just add those coefficients, those real numbers. Okay. All right. So u is going to be 5i minus 3j. And I'm going to be adding that with vector v, which is negative 6i plus 4j. And so I add just the x components with each other and then just the y components. So here I get negative 1 and 1. And we don't have to write the ones. Okay, and if we have this, 4 times u minus 5 times v, then we are going to multiply the vector u, which is 5I, minus 3j, and then negative 5 times vector v, which is negative 6I, plus 4j. Okay, and then we'll combine them. So here we would get 20I minus 12j. And then here, again, you could either distribute the 5 and keep it subtraction, or you could distribute the negative 5, and this will become addition. Okay, so I'm going to do negative 5 times everything inside. Okay, and then here I get negative 20j. And then now I can go ahead and combine my I components. I get 50. And combine my j components, and I get negative 32. Okay, so that's it. So you know both forms. So if you have vector u, some random vector like negative 3, 5, that's going to be the same as this vector written in ij form, negative 3 plus 5j. Okay, they mean the same thing. Okay. All right, so that is it. If you have any questions, make sure you get a hold of me somehow.